Hey, howdy everyone. In this lecture right now, what we'll do is just go through demonstrations for how to work with tabular data. I'll record another video where I'll talk about how to work with gridded data in Python. We'll do it in Jupyter Notebook. So this demonstration is available to you. It is in Jupyter Notebook, and you can download it directly from GitHub. All you have to do is go to GeostatsPy to the Python Numerical Demos repository, and there is under Python Data Basics, DataFrame. And so if you download this and open it up in Jupyter Notebook, you will have got exactly where I am right now. And you'll notice at the top of this notebook, now let me just make a couple of comments around working with Jupyter Notebooks. Just in case this is your first experience with it, you have all of the options here as far as opening, loading. You can, if you're done with a file and you want to save it back as a Jupyter Notebook in another location, you can download it as a Jupyter Notebook. It will default to your download directory. You can copy it from there to some other location. You can also just look at the Python directly and so forth. Also, you can rename, you can make copies of any one of your Jupyter Notebooks at any time. The other thing you'll notice about Jupyter Notebook is that this is code, but it's divided up into blocks. And so the blocks can either be code or markdown. And so this block right here is documentation. It's an introduction to what I've done here. It talks about why you might be interested, the project goal, and so forth, and then it gets into loading libraries. Well, if you double click on this, you'll recognize that this in fact is written as markdown, and if I push the run command up here, it's then converted into the output from that markdown, so it provides us a very nice way to build documentation. You'll notice here these aren't great equations or very interesting, but they are equations. You can, if you're familiar with LaTeX, you can do the same types of things with enumeration, equations. I wrote my PhD thesis in LaTeX and some of my early papers, so it's a very powerful thing. Markdown has the same type of benefits of being able to write equations and formatting in a very nice manner. The links are built in and really nice hyperlinks and so forth. Okay, so let's go through this workflow. It's going to help us with the basics of working with tabular data in Python. So our first step will be to load the required packages that we want to work with. We use the import command, and so we can say, okay, import OS, NumPy, and Pandas. I tend to work with very standard packages that will be part of the default Anaconda install, as much as possible to minimize your need to install brand new packages. So keep it very simple. When we have to install packages, I will help you by providing instructions on how to do that. But it's pretty straightforward. You'll notice that we say import NumPy as NP. From now on, we can do NP dot and access any one of the functions available within NumPy. And Pandas, we have PD, so we can access any of the functions available within Pandas by just doing PD dot. The next thing we want to do is we want to set the working directory. This is a very convenient thing to do because now when we read files, write files, we don't have to write the entire address for the file. We can just put the name of the file and we'll know where it's going. If we don't do this and we go ahead and just say file names, then we're always wondering, well, what's our current directory? Where are things gone? I just find it much more handy to just explicitly state what the working directory is, so I know everything's going to be done in that directory. Of course, you can change it during the process of your workflow at any time, and you could create a workflow that spans multiple subfolders, of course. Now let's talk about loading data. We're going to load the data set 2D MV, which is multivariate 200 wells, comma delimited. It's a tabular data set that's comma delimited. It's available to you on GitHub, GeostatsPy repositories, specifically the GeoDatasets repository within my account, GeostatsPy. And so if you download that, copy it into your working directory, whatever you specified, you'll be able to run this command and it will load it in. Now this command here, PD, means that it is a function within the Pandas package. Read CSV is going to read in that comma delimited tabular data set with this name. And it's going to create, its output is a data frame. And I said the data frame is going to be denoted or named as DF, as in data frame. So this command will create DF, a data frame, with this data set now within a data structure that we're ready to work with. Now let's go ahead and prove that we've loaded it. And so a great way to do that is use the print command. The print command is quite general. You can use it at any point in your code to print out what's going on as far as an object, some variables, and so forth. You can print it. And so when we print DF, we don't want to look at all of the data. It's going to be too many data. It's around 200 wells or so. And so we use the .ilock, which is a function built into data frames that allows you to splice or take a part or section of the data frame. 0 through 5 says we want to take the first 5 rows. And colon tells us that we want to take all of the columns. We want to see all of the variables. So let's go ahead and execute this line of code. So we can go up to the run command and we go ahead and run this. Now, before you do this, make sure that you've run these previous blocks, including this one up here where we import the libraries. I didn't mention that explicitly. If you don't do that, you will not have imported these packages, I should say. And you have to run the one where we set the working directory. I just did that. Now we select this blocks right here and we're ready to run it. If we run it, look what we get. We get the first 5 rows, the row with the names of the properties, the titles, and the first 4 wells with their locations X, Y, a facies assignment with some information here about thresholding, porosity, permeability, acoustic impedance at the well locations. That's all available to us. Now, this looks a little messy. It's not very clean. We could also use the function built into data frames called head. Now note with this function, it's got some parameters. So we have parentheses to represent the fact there's parameters to it, but we're not going to set any of those parameters. We'll let the default run, and let's go ahead and run that. We can comment out this print command by putting the ampersand symbol here, and that turns it, notice it turns into italics, kind of a blue color. It says this code won't be run. It's a comment. It's just like over here, these are treated as comments, and so they're useful for instruction, or we can use it to block code so it does not run. Let's go ahead and run that. And look what happened now. We got the exact same output. Now it's a little bit cleaner. It's a nice table for display. And so the head command gives that to us. We can also specify the number of rows we want to look at. But for now, we're happy just looking at the top. We can see that our data was loaded. It looks pretty good. We could compare this against the raw data file. We can compare this against the data file loaded into Excel. And we'll see that we've in fact loaded it correctly. Now, data frames has a lot of convenient functions built into them, and one of them includes this function right here to describe the summary statistics from the data frame. All at once, you get many summary statistics. Now, I find it's more convenient, and others have shown this online, to transpose it so that we can visualize it, basically reversing the X and Y, and you'll see the result right here. We go ahead and run that, and this is what we get. We get a table where we have the summary statistics on the top, and we have the different variables, the properties of interest, including X, Y, and facies, porosity, permeability, and acoustic impedance. If we had not used transpose in this command, this is what it would look like. I find it easier to look at with the transpose, but you could do it either other way. We're just flipping it, the X and Y. So you might look at that and say, well, those names are awkward for the properties of interest, and it will just take too long to type them in every time we run a step. So let's give ourselves simple names for our properties of interest. How do we do that? DataFrames has a built-in function called rename. And so all you have to do is use the rename command, and then in the parentheses, we specify the columns that we want to work with, and we just put the column name in quotes, colon, the new column name, comma, the current column name in quotes, colon, the new column name in quotes, comma, and so forth. And we can keep doing that through all of the properties. And if we run the head command again, this is what we'll get. And if you look and compare the difference between these two tables, all we've done is change the names of our properties of interest. This is very useful because we will be running many commands that will use these properties. Let's use something really fast and easy to type so we don't mix it up, so we don't always run into having to look back and see what the name was. Now, it's pretty straightforward to try to extract subsets from this. You'll notice up above here with the ilock command, we were able to extract a subset just for the purpose of visualizing it. But maybe you want to, in fact, do that in order to create a new data set, a new data table that has a reduced set of data. It doesn't have all of the data in it. And so the way we would do that is we can just say DataFrame dot, so our DataFrame object, access the member function ilock, and we'll just specify section or splice the first 4 rows from the data set, 0 through 5. I may have misspoke before. When you specify it like this, it means take 0, 1, 2, 3, 4, but not 5. And we would say take specifically the columns 2 through 6. 2, 3, 4, 5, 6. Columns 0 and 1 are omitted, and that is the X and the Y. Now, I had a little rerun here, so you can see that I've already run it. I'll run it again just for you, and you can see, in fact, that this is what we get. We get the first 5 samples, 0, 1, 2, 3, 4, not 5, but we get the first 5 samples. We get facies, porosity, permeability, and acoustic impedance, but we've lost X and Y. So in this way, we could subset any data frame and work with any specific set of columns and rows and so forth. Now, you might be interested to add a new column to your data frame because you've loaded it in, but you may want to do things, use operators that create brand new properties or combinations of properties or some type of statistics and so forth. So you might want to do that. And so here's how we do it. Now, with NumPy, we can create an array full of zeros, a one-dimensional array full of zeros just with this command right here. 200 is the number of entries within the array, so we have an array, one-dimensional, with 200 zeros created by this command right here. And then we can say, okay, take that array, turn it into a series. So a Pandas series is exactly what it's working with within the data frame. Each one of the data properties is represented as a series. So we can convert the ND array directly into a series, then just simplify it to make sure it goes across exactly properly. And we'll say, okay, now add that to the data frame that we have, but call it 0, and then let's look at the head. If we do run that command, look at what we've done. Is we've now created a brand new column within our existing DF data frame, and its name is 0, and all of the values are 0. In fact, if you visualize the whole thing, you would find out that they in fact are all zeros. In fact, if you're curious, we could actually go ahead and just erase that part and say just type DF and run that. And when you do that, you're actually trying to visualize the entire data frame. Now, there's a natural truncation that goes on here to prevent you from looking at things that are too big. You could, of course, there are other methodologies by which you can force visualization of the entire data frame, but we're not going to look at that right now. Let's just go back to our head. Now, you might look at that 0 column and go, well, I didn't really want to do that. That doesn't make any sense to me. So I want to drop it now. I want to get rid of that 0 column. So we can remove a column. And the way we do it is by using the drop function that's built into data frame. So df, our data frame, drop, the column name, and we just specify the axis. So it knows that we're dropping a column by saying 1. We're not trying to drop a row or anything else. We're just trying to drop a column. And so we defaulted or set it as axis 1. And then we can go ahead and take a look and see what we get when we run that. And 0 is now disappeared. The 0 column is gone. Now you might want to do some type of mathematical operation. Something that'd be pretty obvious to do is you might want porosity represented as a percentage, not as a fraction. To do that, we'd have to multiply porosity by 100. So let's create a brand new property in our data frame, df, porosity 100. It's a percentage now. And so what we do is we say that's going to be equal to the data frame values within porosity, which is the current values for porosity, times 100. When we run this command, the data frame will automatically loop over each one of the rows, each one of the entries or samples within this data table, and it will repeat the operation. Porosity times 100 equal to porosity 100, a new column value. We could also create a property which is the permeability divided by porosity. In the calculation of a Lorentz coefficient, this is used and then used to sort the data set in order to get at the Lorentz coefficient. So we might want to do that. We'll call the new property permpor. It's the data for our current data frame, perm, divided by the current data frame porosity value. So now what we're going to do is we're going to take perm value in the first row, or this should say the 0 row. Everything in Python goes from 0 to n-1. So in the 0 row, divided by porosity in the 0 row is equal to the new property permpor in the 0 row, now loop over all rows. Let's go ahead and run that command and see if that's what we get. And we can quickly verify that we in fact have done that. Let's take the first row here, the first well or sample. We've got 0.1184 times 100 is now 11.84. That's fine. We also have permeability 6.1 divided by the porosity value of 0.118. If you get your calculator out, you can immediately confirm that that's 52.1. And so this is working just fine. Now, you might also be interested in applying a conditional statement where you want to create a brand new property that depends on the value of another property. Conditional statements are very useful when it comes to truncating, when it comes to making bins or some type of categorical variable based on existing properties within your data frame. So let's do that. We can use the where command. What the where command will do is it allows us to use a conditional statement in our data frame. And so we can now say NumPy where, and then what we'll say is data frame, our current data frame, porosity column, greater than or equal to 0.12, set the value as high, otherwise set the value as low. And this is now going to be put into our data frame as a brand new property, T porosity, truncated porosity. And we go ahead and run that and we can confirm that the result makes sense. We have a porosity of 0.1184 below 0.12 and we get T porosity is low. All of the other porosities you can confirm are higher than that threshold. We get a value of high, and that's been repeated for all of the entries within our data table. So this is very powerful. It allows us, now there's many ways to do these types of truncations. This is one approach using the np or numpy where command, but there's other approaches, of course, that are available to you. Now let's look at another example of a conditional statement. In this case, we're going to work across two different existing properties, which is kind of interesting. We're going to create a new property called perm cutoff. And what we're going to do is we want to assign the permeability to be a low threshold for any porosities that are low. So what we're saying is that that permeability is no longer effective. The porosity is too low. Now I recognize that 0.12 would of course be too high of a porosity to assign such a threshold, but it's an interesting exercise for demonstration. So if the current, in the current data frame, porosity is greater than or equal to 0.12, keep the permeability value as it is. Just use the current permeability value in the current data frame under the name perm, which is of course our current permeabilities. Otherwise, set the value to be a small value, 0.0001 millidarcies. Okay, let's go ahead and run that command and see what we get. Okay, and look at what we got. We only have one case of low porosity in over the summary from the head command, and that is the first row. And we look at that value. It of course had a porosity, as we saw before, less than 12%. It got an assignment of low in the truncated porosity, and the permeability with the cutoff has now been assigned to that low threshold, while the other permeabilities you can confirm are the same as they were before, because we said otherwise. We said if it's greater than 12% porosity, use the current permeability, otherwise set it as the low threshold. And so this is working between multiple variables. What about the case where we want to work with missing values, not a number? These are denoted as NaN within NumPy. And so what we can do is we don't have any missing values in our current data frame, so let's create one. Let's set one value as missing. And so once again we go to the functions built into data frames. So we take our data frame, go dot, use the function set value, and we say we want to set a value within row 1. Now note the rows go from 0 to n-1, so that's the second row. Set the porosity value, porosity, equal to NumPy np.nan. So nan in NumPy is a recognized variable or value, and so it's saying go ahead and set that as being not a number missing. And then what we can do is we can check with the print command what's the number of null values in our data frame. And so we have a calculation, another built-in function, there's so many of them for data frame, which is null. And it will return null values, and we can do a sum of it, and we'll sum over the columns, and then we can also sum over the rows, I should say, and then sum over the columns. And so we don't want to get an array that tells us number of nulls in the columns or rows. We want the total nulls over the whole spreadsheet, so we do a double sum. And so when we run this command, it'll tell us the number of nulls. We hope that's equal to 1. But then we can go a step further. We can subset our data frame by checking for all in the current data frame porosity values that are null. And this will create a new data frame with all of the rows for which there are null values. And we can print that and look at that. So let's go ahead and run that. So we run that. The first thing we'll notice is the number of null values in our data frame is 1. We searched for the row with a null porosity value, and we found it, and we printed it, and guess what? If you look up here, you'll find that 2585, 1185, it is in fact the second row. We can even see right here the index is 1. But you'll also notice the porosity value has now been set to not a number, that just as we expected it to do. Now you might be disturbed by that. You might say, well, we don't want to work with rows with not a number, with missing samples. Of course, you might be interested in data imputation and how do you deal with that maybe more scientifically, or you might just want to remove the entire sample, which can be a problem at times, but let's just demonstrate that. You have a drop NA parentheses command that can take some parameters. We'll leave it with the defaults. And all it's going to do here is take the current data frame, drop any rows with not a numbers, and overwrite the existing data frame, update it effectively. And let's just take a look at what we get when we run that. And what you'll notice is that index number 1 is missing now. So we have removed the second sample from this data set because it had not a number in it. So in a way, this could be one way of treating a multivariate data set when you're missing values, simply to remove those entries which have the missing value. Okay, so we could it might be useful to go ahead and show a couple of more selections from data frames. How do we extract from a data frame? And so let's do it when we have multiple criteria. And we'll introduce the idea of having an AND operation in doing that. And so once again, we can use the dataframe.lock command. That allows us to be able to identify specific rows within our data frame. And so we'll specify them saying we want to find rows for which the porosity is greater than 12% and the permeability is greater than 10 millidarcies. And so we will now have an extraction of our previous data frame that meets that criteria. And so this is very useful. If we want to identify specific entries to do specific things with them, we can go ahead and run this command. And if we run the command, what we're going to get is we're now going to get well, you notice, first of all, they're all high porosities. We removed this porosity value because it had a porosity less than 12%. If we look through, we'll also see that the permeability values are also all going to be high, that the permeability values are all going to be above 10 millidarcies. And so we've lost a variety of different entries, like entry number 3, because entry number 3 had a high enough porosity, but the permeability was too low. It did not meet that criteria, so it's removed. And you can look and so forth. You'll see quite a few have been removed. 2, 6, 7, 13, 15. A lot of entries were removed by this selection criteria. So what if you want to make a brand new data frame? So let's go ahead and extract information from our current data frame into a very raw format, either a series or as NumPy ND arrays. And then we're going to take these ND arrays and put them together. Now let me show you something. If I do this command right here, and I do por equal my current data frame, the name porosity, so all of the porosity values, and by putting this values command, it says extract that as a one-dimensional ND array. Now you might say, hey Michael, I don't know how you know that. Well, what I did is I just added this line of code just to make sure I could show how to check that. So I repeated this line of code right here. I'm extracting values from porosity column within the data frame. And if I run that, it says the type is equal to a NumPy ND array. So it's a 1D array. I can in fact just go ahead and type its name. At any time you can just type its name, and you can see in fact that this is just simply a simple array of values. You can also type the shape command. If you do that, it tells me that in fact it has 199 records. Now somebody here might be saying, hey Michael, I thought you said this was 200 wells. Well, remember we created that null value and removed it from the record, so we have removed one record so far with our workflow. Now you might be interested what happens if I go ahead and remove this values command right here. What do we get here? Well, now check that out. Now you're seeing a Pandas series. So it's just a different type of data framework, or a different type of data for the purpose of the most raw form for working with gridded data and arrays and so forth. I like to work with ND arrays, and so that's why we put the values here. Also, I demonstrate that we can take ND arrays that are one-dimensional and combine them together into a data frame. Now, of course, we can cut this block away and get back to work. Get back to work already. So we'll go ahead and create two one-dimensional ND arrays of porosity values and permeability values. And then we have this command right here, Pandas, the Pandas package, data frame command creates a data frame. And so we just put these curly brackets inside the parentheses, and all we have to do is specify what's the name of the column we want, the name of the property, the ND array that we want to use to represent that, the name of the property, the ND array, and we could just keep repeating that for all of the variables. And so by running this command, what we've done is we've in fact created a brand data frame with only the porosity and permeability properties on it. And so we could do this. Now, of course, these 1D arrays could have come from any sources, and we could have created a brand new data frame from scratch by combining a variety of different sources. This is very convenient for getting the job done. Now, of course, we can retrieve different information about our data frames. There's a variety of different built-in variables that can tell us things about the data frame. So there's the index, the columns, the values, and so we can go ahead and print them and just take a look and see what we have there. The index is going to be these values right here. 0, we killed or got rid of 1, so now it's 0, 2, 3 through 199. We got the columns, which is the columns names, the properties, X through permeability cutoff. And then we got the values, which is actually a way to directly access the entire two-dimensional array with all of the values associated with it. Now you can also use the list command, and this is pretty useful to get a list of the feature or property names. And so if you do that, you can see all of the features or property names that way. Now you can be a little bit more surgical in the way that you interact with the data frame. You might be interested in doing something like retrieving the fourth column feature name, or the porosity value for sample number 1. And so column 2 is equal to, column 2 name, we'll say it's equal to the columns square bracket saying the value at the third index or the third case. And so we'll set column 2 to that name and we'll print it. And then we'll access the two-dimensional matrix with all of the values, the raw matrix, and say, let's go ahead and take the value that's in the second row, remember they start at 0, and the fourth column. And so if I do that, I'm going to get, let's just run that and take a look at what we get. Oops. If we run that, we'll find that we get the column name for the third column is going to be set to, or sorry, for the fourth column is set to porosity. So we can go up to the original table. We'll go all the way up to the last time we looked at it. So we have 0, 1, 2, 3. So this is going to be our porosity values right here in the fourth column. And we asked for the value within the second row for porosity, 0.1920. We come back down here and see what we actually got. We see that the porosity value for that second row, because it goes from 0 to 1, 2, and through n minus 1, is equal to 0.192. And so this is very surgical. We can reach in and look at a specific column property name. We can reach in and see what is a specific value from the data frame, and so we can get to them by using these types of commands. We can manually change the values too. Here's an example of manually changing the value for porosity from the third column. And so we can go ahead and we will check that value. We can use the iloc command in order to get that value, which will be por. We can go ahead and print it. Notice what we have to do here with the print command is we're doing a print command where we're putting text in it. By putting the plus symbol, we say, okay, splice something in. It could be more text, it could be something. Then we convert the data value from por to a string so we can splice it in. And so this is a way just to be able to output it as a sentence, as a print of text. We just turn our property into text and we can splice it in with the plus symbols. And we're going to use the setValue command to set the value at that porosity location to 0.1. And we'll print out saying, hey, we just set this value. Well, let's go ahead and we can confirm it by running the head command and seeing what happened. So if we go ahead and run that command, what we'll find is that the sample 2 started at a value of 16.2%. We said we set that value to 10%. And if we go to our data table, we find that that second sample is now 10% porosity. So in fact, we have reset the value for porosity to 0.1 for that value. Okay, so this was a lot of discussion about different things we can do with data frames. If you put this all together, you're able to do all kinds of operations around loading data, trying to sort the data, to find specific values within the data, to work with missing values, to perform operations where we modify the data to create new columns, to remove new columns, to access specific values, to change specific values, to rename the properties, and so forth. And this gives you a lot of flexibility to be able to work with your data. When you're done, of course, you can use the built-in function toCSV, which remember we read in this data frame originally from a CSV or comma delimited file. You can write it back out using this command. So when you're done with it, you now can store your updated data set or your tabular data. All right, so this is it. If you're interested, go ahead and check out the actual, and maybe you follow along already, but check out this code. It's available to you, as I mentioned before, on the GeoStats Guy set of repositories under my Python numerical demos. And I, of course, am happy to discuss anytime. I'm Michael Perch. I'm an associate professor here at the University of Texas at Austin. I'm the GeoStats Guy on Twitter, on GitHub, and GeoStats Guy lectures are my videos online. All right, I hope this was helpful. Thank you.